Hi, so this is my tutorial for CSCI 30A1, and for this I wrote a simple library for managing settings for programs. So kind of my motivation for this is that a large program and projects typically have a lot of settings, and this is typically in the form of a whole bunch of pound-defined constants, which can introduce bugs and be hard to manage and change easily. And some of the big issues with that are that pound-defined constants aren't type checked, so it's very easy to write the wrong type for something by accident, and that can lead to very hard to find bugs. If you pound define something multiple times, that doesn't actually get warned at all. And when you're trying to manage pound defines of header files, which are recursive, or run into two header files which are mutually recursive, you can run into weird cases where you don't know where to put the definition and end up having to create another header file. And generally, it makes things difficult for testing and debugging stuff because you have to go in and change something in your code, recompile, test, do whatever you're doing, and then you have to go back in, change it back. Oftentimes you have to remember what it was in the first place, and then recompile again and keep working on stuff. So my purpose here is to find a better alternative to this. And so I wrote a library that loads settings at runtime from external configuration files, which basically replaces most cases where you need to use pound defines. And even though it is done at runtime, it still has almost no performance hit. So what I did is I created a system where you can have a human readable data format, and type definition or type checking and checking for if there's a redefinition for something also gets done. And there's an easy way of setting variables from the command line and changing the values, which makes debugging much easier. There's different formats for specifying values, such as like octal or hexadecimal, and it's basically a lot of the same capabilities that you would get with using the C preprocessor directly, and it's very easy to use. Like, there's not really any external code that needs to be passed around to pass around values, which is another benefit because you'll end up cutting down on the number of constructor parameters very often. And the types you can use with it are ints, floats, booleans, characters, and strings. And then ints you can specify as hexadecimal or octal, which makes it kind of useful. Like if you're doing something where you need an integer with a specific byte pattern, it's easy and handy to be able to write that specifically with hexadecimal. And so you use the library. You include the file configuration.h is the header file, which has the definitions in it, the interface. And then in main, you'll call a function initconfig and tell it what file to use to load. And you can also pass in the command line arguments so that the library can use that to set variables from the command line, which is very useful for debugging. And then also, when you actually need to use a value from it, it's very simple. You just have a macro get type, so the types are int, float, bool, char, string, all capitalized, and then you just pass in as a string the variable name. And so the format that you actually specify the files as, it's fairly familiar and readable syntax. It's just the type and then the name of the variable equals and then the value, and you can include other files with use, and then you pass the file name as a string. And so that basically works the same as pound include in the C preprocessor for header files. And then you can have comments which start with pound, and they can start at the end of the line or in the middle of the line, and you can also have blank lines. And so here's the different formats for the values. This is all also repeated in the Doxygen, which comes the code which I'm providing with the tutorial. And so it's fairly straightforward. I just have the regular expressions for the values, or maybe a little bit more straightforward, I have some examples of legal strings and ints, floats, whatever. And it's all very straightforward. Um, one kind of a tricky thing is you specify the type name for hexadecimal and octal. You specify it as hex or octal, but it gets saved as an int. So when you're actually accessing that value, it's get int variable name. There isn't any like get hex or get octal or anything like that. And the command line interface for saying values for debugging or testing purposes, it's also fairly straightforward. To use it, you have to pass the argc and argv into the function call when you initialize the library. And then to set a variable, it's just dash capital D with no space, the variable name, and then space, and then the type name, which was on the table in the last slide, and then the value, which is the same as when it's in the file. And so it'll just overwrite the existing value which you declared in the configuration file, or you can also use that to declare new values. There's really no difference with declaring something that wasn't already defined. And the only kind of tricky thing is that when you're declaring or saying strings or characters from the command line, you need to have backslashes for the quotes, which I'll show in the demo in the next video, because otherwise the shell interprets the quotes as just a literal string which you're trying to pass in, and the quotes don't actually get passed into the function or the arguments to the program. So that's just something to be aware of to make sure you escape them. And also you can change the default file which you're loading the settings from, or add an additional file to add more settings from, or change the values of the settings. It's just dash use config or dash add config. It's also very simple. And then it also does some error checking. So basically it prints an error message and exits the program if it finds a syntax error or in the file, or when you type something in on the command line, or if you don't find a value that you requested in the program, it doesn't find that in the file. Or if it does find it and has the wrong type, it prints an error message and exits the program. And it'll print a warning if, like, for example, a value is redefined. So if you have it twice in the same file, or you include a file that redefines it or something like that, it'll give you a warning. And when it gives errors, the line numbers that happened on in the configuration file is reported when that makes sense. Just one thing to be aware of is that I haven't yet implemented solving the problem with when you have recursive includes. Like if you have file 1 that includes file 2 and file 2 that includes file 1, well, in the C preprocessor you solve that with guards, where you say if and def whatever, pound define whatever, and then your header file, and then pound endif. Or with newer compilers you just have pound pragma once. I haven't implemented that yet with the configuration files, but it should be fairly straightforward to avoid that in the first place, because files and variables don't have direct dependencies on each other ever. And also, something else to be aware of is that the files don't actually get loaded right away. That gets deferred until the first time that you actually request the value from a macro call or whatever. So you may not actually get, like, if there's a syntax error in the configuration file, it might not actually get reported until you're well into writing the program. But if you have a syntax error when you type something in on the command line, that will get reported immediately. And so in the next video I'll have a simple demo of an example using this library.